Hi, this is Osama Al-Amrani. I'm a grade 9 student at Al-Nada Modern School in Sana'a, Yemen. Today I'll be talking about oxidation. Have you ever wondered what oxidation is and why it's important? Let's dive right into it. Oxidation, at its core, is a fundamental chemical process that's happening constantly everywhere around us. It's a fascinating dance of electrons, where oxygen, an element that's essential for life as we know it, grabs electrons from another substance. This process changes the nature of that substance, and it's this change that we call oxidation. Now, let's take a closer look at a familiar example of oxidation that happens right in our kitchens. Imagine biting into a fresh, juicy apple. You take a few bites, set it down, and come back to it a bit later, only to find that the exposed flesh of the apple has turned brown. That browning, my friends, is oxidation in action. When you bite into the apple, you damage its cells, exposing enzymes and other substances inside to the air. The oxygen in the air reacts with these substances, particularly an enzyme called polyphenol oxidase, setting off a cascade of chemical reactions. These reactions lead to the production of melanin, a brown pigment, which you see as the browning of the apple. This is a classic example of an enzymatic browning reaction, a type of oxidation. This might seem like a minor everyday occurrence, but it's a testament to the power and pervasiveness of oxidation. It's a process that's not limited to our kitchens or even to our planet. It's a universal phenomenon happening at every moment, in every corner of the universe where oxygen exists. This simple apple browning process, however, is just the tip of the iceberg. Oxidation plays a vital role in countless other processes, from the rusting of iron to the burning of a candle, from the functioning of our bodies to the life of a star. So, the browning of an apple slice is a simple example of oxidation, but why is it important? Stick around as we unravel the mysteries of oxidation in the next scenes. Did you know that oxidation is also happening inside your body right now? Yes, indeed, it's not just a process that causes your apple slices to turn brown or your iron gate to rust. It's a fundamental reaction that fuels life itself. Let's dive into the fascinating world of our body's internal chemistry. At the heart of it all is the process of oxidation, an incredible mechanism that helps convert the food we eat into energy. Think about it. The sandwich you had for lunch, the apple you nibbled on, or the water you sipped. All these substances, once in your body, have to be broken down into simpler forms. This is where oxidation steps in. Now, let's take a closer look at how our bodies oxidize glucose, a simple sugar that's a primary source of energy. When glucose enters our cells, it's broken down during a process called glycolysis. This doesn't require any oxygen and results in a small amount of energy, along with a molecule called pyruvate. But the real magic happens next. This pyruvate is ferried into the powerhouse of the cell, the mitochondria, where it's further oxidized in a process called the Krebs cycle. Here, with the help of oxygen, pyruvate is transformed into carbon dioxide, water, and most importantly, energy in the form of a molecule called ATP. ATP, or adenosine triphosphate, is the energy currency of the cell. It's like the fuel that keeps our bodies running. Every cell in our body uses ATP for energy. It powers our muscles when we run, it fuels our brain when we think, and it even keeps our heart beating. So you see, oxidation is an unsung hero in our bodies. It's the process that allows us to convert the food we eat into the energy we need to live, to learn, to love, and to grow. It's the spark that ignites life within us. So oxidation isn't just about browning apples, it's also about powering your body. Have you ever seen a rusty old car and wondered what caused it to rust? We're about to dive into the fascinating world of chemistry to find out. Much like the previous examples, the answer lies in the process of oxidation. Imagine a piece of iron left out in the open. The iron atoms on the surface of the metal come into contact with oxygen in the air. This interaction leads to a chemical reaction. The iron atoms lose electrons to the oxygen atoms. This is oxidation. As a result, iron oxide is formed, which we commonly know as rust. But why does this happen? Well, the atoms in the universe are a bit like us, always striving for stability. Iron atoms have the capacity to lose electrons, and oxygen atoms have the capacity to gain electrons. So when they meet, they exchange electrons to achieve a more stable state. This exchange of electrons is what we call a redox reaction, short for reduction oxidation. Now, you might wonder, why does rust look so different from the shiny grey of iron? This is due to the molecular structure of rust. Iron oxide molecules are larger than iron molecules. So when iron turns into rust, it expands, causing the flaky, crumbly texture we associate with rust. Also, rust is not as strong or durable as iron, which is why we often see rusty structures crumbling away. This process is not only aesthetically displeasing, but can also cause significant structural damage over time. This is why we take measures to prevent or delay this process, like painting iron or steel structures or using rust-resistant materials. So next time you see a rusty old car or a weathered iron bridge, you'll know what's happening on a microscopic level. It's the dance of the atoms, trying to achieve stability, leading to the transformation of iron into rust. The rust on an old car is another everyday example of oxidation in action. Did you know that fire is also a result of oxidation? Yes, you heard it right. Just like rusting, the fiery flames that dance in a fireplace or a bonfire are also a dramatic display of oxidation in action. To understand this, we first need to grasp what oxidation really is. Simply put, oxidation is a chemical reaction that involves the movement of electrons. When a substance loses electrons during a reaction, we say it has been oxidized. The substance that gains these electrons is known as the oxidizing agent, often oxygen itself. Now, let's bring fire into this equation. When something burns, it's reacting with the oxygen in the air at a high speed. This rapid reaction releases heat and light, the two main characteristics we associate with fire. Take a piece of wood, for instance. When it catches fire, the carbon compounds within the wood react with the oxygen in the air to produce carbon dioxide, water vapor, heat and light. This process is known as combustion, which is a form of rapid oxidation. In other words, fire is an extreme example of oxidation. It's not as slow as rust forming on an old car, or as quiet as the oxidation happening in your body right now, but the underlying chemistry is the same. It's fascinating to think that the same process that causes a metal to rust is also responsible for the warmth of a campfire or the heat from a gas stove. It's all oxidation, just at different speeds and scales. So whether it's a flickering candle or a roaring bonfire, remember that these enchanting flames are more than just light and heat. They are a spectacular demonstration of the power and beauty of chemistry. They show us how the seemingly simple process of oxidation can result in such diverse and remarkable phenomena. So next time you see a fire, remember that it's an extreme example of oxidation. And that, my friends, is the burning truth about fire and oxidation. So we've seen some examples of oxidation, but why is it important? Well, let's take a moment to unravel the significance of this seemingly complex process. Oxidation, in fact, is not just a fancy scientific term. It's a process that's deeply intertwined with life and the world around us. First and foremost, let's talk about our bodies. Oxidation plays a pivotal role in our survival. It's involved in the very act of breathing, which is, needless to say, a rather important process. When we inhale oxygen, it enters our cells where it undergoes oxidation to produce energy. This energy powers every single activity, from your morning jog to your midnight snack raid. But oxidation isn't just an indoor event, it's an outdoor spectacle too. It's part of the reason why the leaves change color in autumn, painting landscapes with hues of red, orange and gold. The process of oxidation changes the color of the chlorophyll in leaves, giving us the breathtaking autumn colors we all love. Oxidation is also a star player in some major global processes. It's involved in the creation of our atmosphere, the weathering of rocks, and even the rusting of iron. It's the reason why your bike turns a rusty brown if you leave it out in the rain. And let's not forget the role oxidation plays in the culinary world. It's responsible for the browning of apples when you leave them out, and the delicious crust on your bread. In the world of energy production, oxidation is again a key player. It's involved in the burning of fuels, from the petrol in your car to the coal in power stations, releasing energy that powers our lives. So you see, oxidation is not just a scientific concept confined to textbooks. It's a process that's happening all around us and inside us every single day. It's essential for life, for the world as we know it, and for those autumn days that we all cherish. So oxidation might seem like a complex scientific concept, but it's actually a simple process that's happening all around us and inside us every day.